Hello, in this video we're going to look at reconstitution of meds. So by definition, all that this is dissolving a powdered med in an appropriate solvent or diluent. Some vocab that you may see in these problems: the solvent or diluent is referring to the liquid that is added. The solute is the powder you start with, and the solution is the mixture of the two. Now, the thing to look out for is the displacement factor. And this is when the total volume is greater than the amount of solvent added because of the powder that was originally in the container. So our strategy when we're working with this is to make sure that we use the exact amount of diluent from the directions. And as long as we do that, we will get the correct dosage strength. Thankfully for us, they figured it all out in the lab, so they have accounted for the displacement factor, and we just have to find the pieces of information that we need. If we as the nurse reconstitute the med, then it is our job to put the time and date of reconstitution on the container. It is our job to initial, and typically that requires credentials as well. And then it is highly recommended that you circle the dosage strength so that it's extremely obvious to anyone else who was going to use the medication. So as we encounter these meds in word problem format, we're going to see that there's extra information that we don't need for the calculation because of the reconstitution. So let's take a look at this first one. The doctor has ordered amoxicillin 0.5 grams via a nasogastric tube every 6 hours. From that first sentence, the thing I need is the amount ordered. So 0.5 grams is serving as my order. The second sentence, the amoxicillin's label reads, add 78 milliliters of sterile water to yield 250 milligrams per 5 milliliters. How many milliliters should you get? Well, the two things that are told to us here is this water for reconstitution. So this is telling us how much to add to the container. We need to do that exactly so that we have the correct strength. The strength is this 250 milligrams per 5 milliliters. The strength is what we've always been looking for to do the math. So even though I need to add the liquid, the 78 milliliters of sterile water, to make this med usable, I do not use the 78 in my math calculation. So let's give it a try. I'm going to use the dimensional analysis strategy, which always starts with the order 0.5 grams. Places it over 1 to have it as a fraction. When I look at the strength that I've identified, I see that the strength includes milligrams, so that's not going to cancel. One strategy is to use King Henry, and he died by drinking chocolate milk full of microorganisms. Gram is the base unit, and I want to get it to milligrams, so I'll move my decimal 3 places. So that converts to 500 milligrams as the order. I set up my second fraction in dimensional analysis with the 250 milligrams in the denominator so that it cancels milligrams. Then 5 milliliters is also part of the strength, so part of the same fraction. And then I do my math, and I come out with 10 milliliters. Now, as I've shown you in other videos, we can do this all at once if we have memorized our conversions. So the other way to do this, still using the dimensional analysis strategy, is to start with the 0.5 grams over 1. Use our memorized fact that 1 gram is 1,000 milligrams. That will allow us to cancel grams. And then again, we will use the strength of the medication, so the 250 milligrams in the denominator with the 5 ml. And when we multiply straight across and divide, we end up with the same answer. Now, you will clearly notice that in either strategy, either setup, I did not use the sterile water because that is needed to reconstitute the medication, but it is the strength that is needed to do the math calculation. So let's take a look at another example. In this one, we actually have the label. So we don't have as much information in the word problem. It says that 462 milligrams as an IM every 8 hours is ordered for an adult male weighing 325 pounds. So in all of that information, I need the ordered amount. So I need the 462 milligrams. I start my dimensional analysis setup by putting the 462 milligrams over 1. Now I'm going to look at my label because I'm going to need the dosage strength in order to do the conversion. So the first thing that I see is in this black box, I see 1 gram, but I have an issue there. It does not give me a conversion. It does not give me a milliliter amount to go with it. So I'm going to go over to the fine print, and I first read for IM use, and that's encouraging because my order is for IM, so I'm reading the right information. It tells me to add 2.5 milliliters of sterile water for injection. So this is the amount of water to reconstitute. Important information. I have to measure that and add it exactly right to get the correct strength. So I have to keep reading. Shake well. All right, that makes sense because then the powder would dissolve. And then it says provides an approximate volume of 3 ml. And then it gives me that information that I'm looking for, that conversion or strength, 330 milligrams per milliliter. So I'm going to take the 330 up to my dimensional analysis, put it on the bottom so that this counts as 330 milligrams, 1 milliliter on top, milligrams cancels. So you can see that here on the label are the 2 things that we talked about. We have the amount of liquid that we need to add to reconstitute this, and then we also have the strength. And so both pieces are important, one to physically add the water, and the second one to do the right calculation. And so I do this on my calculator, and I end up with 1.4 milliliters. All right, so we're going to take a look at another label. All right, so I have a whole list of questions here. They're actually really short questions. So first thing it says is that we have an order of 0.375 grams as an IM every 6 hours. So this is my order, and I know that in my dimensional analysis strategy, I would start with that 0.375 grams. Put it over 1. When I look at the label, the first thing that catches my eye is up here, this 500 milligrams, but there's no volume with that, so that's not something that I'm going to be able to use, so I'm going to have to read the fine print. And so I go over here, and it says, before reconstitution, protect from light, store controlled room temperature, tells me usual adult dosage, and then I see really good stuff. I see 4 IM administration, and this order was IM, so I'm reading the right section. Administer 4 IM administration, add 2 milliliters of sterile water for injection. So what type of diluent should I use? Well, that's what should you add? And the answer is the sterile water for injection. Sorry, my handwriting's looking atrocious there. How many milliliters? Well, I just read that. That's 2 ml. Was there a displacement factor? So this is asking me, did the powder add some additional volume? So I'm going to keep reading. Shake well. That makes sense. That's so the powder gets dissolved. Withdraw the entire contents. Provides an approximate volume of 2.2 milliliters, 225 milligrams per milliliter. So seeing what I need here. I see the strength, which I'm putting a box around, and I see that the volume is 2.2. So was there a displacement factor? And the answer is yes. And that means I know this because the powder added 0.2 milliliters of volume. So in Part B here, I'm adding 2 milliliters of diluent, but then the total volume is 2.2. So even though I shake that really well and the powder dissolves, it adds volume. That powder still takes up space. So they're asking me next, Part D, what is the strength? So we noted that as 225 milligrams per milliliter. And we're going to need that key piece of information to do our math. How long is it stable? Well, that's the next paragraph, and it depends on how you store it. So it's stable for 24 hours at room temperature or 10 days if we use refrigeration. I'm not going to write that all out, but you see the answer. Part F, what 3 things did you put on the bottle? Well, the first is that you should put on the time and date. And the second is your initials. And then you should circle the strength. So I already have the box around the strength. And unfortunately for you all, I'm a math teacher, so my initials don't mean a lot, but yours will eventually have RN after it, and that is that qualification that you need when you reconstitute. So finally, how many milliliters to administer? Well, I'm looking up here where I started my dimensional analysis at the top, and I see that this is in grams, and I've done this a number of times, so I know to move my decimal 3 places. So I get 375 milligrams. And my strength, which I've noted a couple times, was 225 milligrams, which I put on the denominator, 1 milliliter up top. And when I do that math, I get 1.6 repeating, which is the first time that I've gotten a decimal that's going to need rounded. And so what I need to think back to is how should I round? And so since this is greater than 1, I should round to tenths. Because greater than 1, my syringe is going to be marked off in tenths. And so that's what's going to be a measurable dose. And so seeing that the next number is a 6, I will round it up. And I will give this patient 1.7 milliliters as the correct amount. So in this problem, we really had to read the fine print because it needed to be reconstituted. So 2 key things when we're reconstituting is how much do you have to add in, and we have that in Part B, 2 milliliters, and then what is the strength, because we use the strength to do the math.